Create a 10 minutes video for YouTube about a bigger object is coming for Earth. And it's not. 3I Atlas. C 2025. R2 SWAN. Explained. While the world watches 3I Atlas, the interstellar traveler lighting up headlines, another object has quietly entered the inner solar system. It slipped through our telescopes, hid in the glare of the sun, and by the time we noticed, it was already heading toward Earth's orbital path. Its name is C 2025 R2, known as Comet SWAN, a mysterious, outbursting comet that was discovered too late and is now sweeping closer than almost anyone expected. It began in early September 2025. Astronomer Vladimir Bazugli was examining ultraviolet images from the SOHO spacecraft's SWAN instrument, a camera designed to study hydrogen atoms in the solar wind. Among the streams of data, he saw something faint, something moving. At first it looked like static, but its motion was deliberate, its glow constant. When the images were compared across several days, it was clear. This was a comet, one that no one had seen before. They named it C 2025 R2, SWAN, after the instrument that revealed it. By the time astronomers confirmed its orbit, the comet had already passed its perihelion, its closest point to the sun. That means for months, while our telescopes scanned the night sky for interstellar objects like 3I Atlas, another icy wanderer was rushing sunward in a direction where no telescope could see. The sun itself had been hiding it in plain sight. Comet SWAN's trajectory came from a near ecliptic angle, a path that keeps it almost level with the planetary plane. That geometry placed it directly behind the sun from our viewpoint. It's an observational blind spot, what astronomers call the Houellebecq effect, when a comet approaches from the solar direction and remains invisible until it re-emerges on the far side. It's the cosmic equivalent of someone sneaking up behind a floodlight. You can't see them until they step out of the glare. This discovery reignited an uncomfortable question. How many objects cross that hidden corridor without being noticed? Modern sky surveys like Pan-STARRS and Atlas constantly scan the heavens, but even they must avoid pointing too close to the sun. For a comet on the wrong approach, we simply wouldn't know it existed until it had already come and gone. Once the calculations were complete, the numbers told a story both reassuring and astonishing. Perihelion occurred on September 12, 2025 at about half the Earth-Sun distance. Its closest approach to Earth will be roughly 0.26 astronomical units, 39 million kilometers. That's close on a planetary scale, about 1/10 the distance to Mars, and only a little farther than the average gap between Mercury and the Sun. Its minimum orbital intersection distance, the MOID, is about 0.048 AU, 7 million kilometers. That's not a collision path, but in cosmic terms, it's near enough to remind us how thin the margins really are. Unlike interstellar visitors such as Oumuamua or 3I Atlas, SWAN isn't from another star system. Its motion suggests it's a long-period comet from the distant Oort cloud, perhaps making its first return to the inner solar system in tens of thousands of years. Its green glow comes from diatomic carbon and cyanogen gas excited by sunlight, a spectral signature seen in many pristine comets. Each time its surface heats, trapped ice bursts into vapor, carrying ancient carbon molecules into space. The result is that ghostly emerald aura, stretching millions of kilometers across the void. Observers soon noticed that the comet's brightness didn't behave predictably. It flared up, dimmed, then brightened again. These sudden spikes are called outbursts, brief explosions of gas and dust when sunlight fractures the crust and volatile pockets erupt. Every outburst changes the comet slightly, its spin, its jets, even its orbit. Sometimes, an outburst can split a comet apart entirely. It's happened before. Comet 73P Schwarzmann-Bachmann broke into dozens of pieces. Comet ISON disintegrated completely after grazing the sun. Comet SWAN's unpredictable brightness makes scientists wonder whether fragments might already be drifting alongside it, invisible to ground-based telescopes. That unpredictability exposes a weakness in our planetary defense system. Even with thousands of near-Earth asteroids cataloged, an object approaching from the sun's direction could escape notice until the last few days. Comets like SWAN are reminders of how limited our view still is. The planned NEO Surveyor mission, a space telescope that will watch in infrared, hopes to close that gap by looking directly into regions too bright for visible light instruments. But for now, the solar blind zone remains real. By October 2025, the comet will be moving outward again, passing Earth's orbit on the far side of the Sun. Around October 20th, it reaches its nearest distance to us, still tens of millions of kilometers away, but within reach of amateur telescopes. From Earth, it should appear as a faint green smudge in the southwestern sky after sunset. For those in Saudi Arabia, Southern Europe, or the southern United States, it will hang low above the horizon for a short time before fading into twilight. Through binoculars, you might glimpse a tiny core and a diffuse tail pointing away from the sun. For astrophotographers, this brief window is gold. A few seconds of exposure could capture the tail's ion stream, a thin bluish ribbon of charged particles carried by the solar wind. But visibility will depend on darkness and clear air. The comet's brightness is expected to hover near magnitude 6, right on the edge of naked eye visibility. Some nights it may brighten suddenly, other nights it may vanish completely into haze. Meanwhile, another visitor, Comet C 2025 A6 Lemon, is also crossing the sky. Together they form a rare pairing. Two bright comets visible within weeks of each other, accompanied by the annual Orionid meteor shower. Astronomers are calling it a twin comet event. Lemon rises higher and stays longer, while SWAN cuts a sharper, quicker path near the sun. It's a once-in-a-generation display for skywatchers willing to chase the horizon. Beyond its beauty, SWAN poses an intriguing scientific question. Will Earth ever pass through its debris trail? Every comet leaves a stream of dust along its orbit. When our planet crosses such a stream, the particles burn up in the atmosphere and create meteor showers. For now, models show SWAN's trail offset from Earth's path, but gravitational tugs can shift orbits over time. Decades from now, fragments from this 2025 passage could drift into alignment, perhaps creating a faint new meteor shower for future generations. Comets like this are reminders of our solar system's fragile memory. Each one carries the ingredients of the early planets: water, methane, complex organics, locked in ice for eons. When sunlight releases them, we glimpse what the cosmos looked like before Earth had oceans or life. Studying their spectra reveals the chemistry of creation itself. In a sense, comets are both messengers and mirrors, showing us where we came from and how much of our cosmic neighborhood we still don't see. Yet there's also humility in the discovery of SWAN. It wasn't found by a billion-dollar observatory. It wasn't predicted years in advance. It was spotted by chance, in data meant for something else. That accidental discovery exposes the limits of our cosmic awareness. Even now, entire worlds can slip through unnoticed simply because they pass too close to the blinding light of the sun. For planetary defense experts, this is a wake-up call. If a fragile, icy comet several kilometers wide can go undetected until it's almost leaving, what about a dense asteroid approaching on the same path? The odds of a surprise impact are low, but not zero. SWAN shows that the weakest link in our surveillance net is still the one closest to home: the daylight sky. As the comet moves outward, astronomers are racing to gather spectra, measure outgassing, and model its spin. Every flare, every outburst adds a data point to the study of cometary evolution. They want to know whether SWAN will survive its solar passage intact or slowly crumble over the next few months. If it holds together, it will fade into the darkness beyond Mars and may not return for tens of thousands of years. If it breaks apart, fragments could trace glittering arcs across our telescopes for years to come. For viewers, the next few nights offer a fleeting chance to see it. Just after sunset, when the sky turns indigo and the first stars appear, look low to the southwest. You won't see a blazing light, Just a subtle haze, a faint emerald smudge barely above the horizon. That is the ancient traveler called SWAN, a messenger from the farthest reaches of the solar system. What makes this moment powerful is not danger, but perspective. In a universe where distances are measured in billions of kilometers, an icy rock passing within 0.26 AU is practically a handshake, and yet we almost missed it entirely. That should humble us, not frighten us. The cosmos is vast, but our attention is small. The comet's journey reminds us why exploration matters, not just to protect our planet, but to understand it. Every comet that slips from darkness into view tells a story of beginnings, of frozen oceans, primordial dust, and the silent forces that shaped everything we see. SWAN's path through the inner solar system is a whisper from the past, a message written in ice. So while 3I Atlas sails onward into interstellar space, drawing attention for its alien origin, the real lesson this year may come from the object closer to home, the one that hid in sunlight, passed near our orbit, and reminded us how easily wonder can be overlooked. Step outside one evening this week. Wait for the sun to sink, for twilight to fade, and for the first stars to appear. Somewhere just above the western horizon, that ghostly traveler will be gliding outward, back into the void. You might not see it with your eyes, but knowing it's there changes something inside you. It's proof that even in our modern age of satellites and sensors, discovery is still possible. The universe hasn't run out of mysteries. We just have to keep looking, especially into the light. Because sometimes the biggest object coming for Earth isn't a threat at all. It's a reminder of how small we are, how much we still have to learn, and how endlessly the cosmos continues to surprise us.